This video is related to the Advanced 3 Learning Unit of the Data Visualization Educational Module. In Tableau Public, we perform ad hoc analysis and create visualizations on each worksheet, but often want to use a Tableau Public dashboard to bring together visualizations and create interactive applications for the audience. In the following slides, the steps for creating a clear and effective dashboard will be presented. Click the New Dashboard button to create a new, empty dashboard. Drag the first sheet that you want to incorporate as part of the dashboard onto the dashboard workspace. In this case, locate the sales map sheet and drag and drop it onto the dashboard workspace, as shown in Figure A in this slide. Drag the second sheet onto the dashboard workspace. It doesn't matter in what order we created the sheets, we can add them as needed to the dashboard. This time, we'll want to drop the product sales and profit sheet onto the dashboard workspace. Release the mouse button to drop the chart in the indicated location, as shown in Figure B. If desired, change the target size of the dashboard by making a selection from the size drop-down list in the dashboard section of the navigation menu on the left, as shown in the figure in this slide. Although the dashboard contains the views that we have added, it might not have exactly the appearance that we would like. For example, we might want to add a logo, adjust the view sizes, or simply move some things around. In the following slides, a couple of things will be presented, in order to organize the look and feel of the dashboard. We can easily add a logo to the dashboard as follows. In the Objects section at Dashboard panel, below the list of worksheet views, select the image item and drag it to appear the logo on the dashboard, as shown in Figure Alpha in the slide. Doing so calls up an Edit Image Object window, where we can navigate to the location of the image file and select it. Click the Open button to add the image to the dashboard. Right-click the image and choose Fit Image from the contextual menu that appears. If necessary, drag the image border to resize the image. The result should look similar to that shown in Figure B. We can also add content from a web page to the dashboard. To do so, drag the web page item from the dashboard panel onto the dashboard. In the Edit URL dialog box that appears as shown in Figure A, in this slide enter the URL for the web page to be presented on the dashboard. Click the OK button to add the web page, as shown in Figure B. After adding all the content in the dashboard, probably the user will find that the layout of certain elements isn't quite ideal. Fortunately, Tableau Public gives the option of moving and also resizing content to fit specific needs. Objects on a dashboard sit inside containers that you can move and resize by using the Fit submenu or by dragging its borders. For example, in the figure in this slide, the container for the product sales and profits is being adjusted with the help of the Fit submenu. We can also add blank objects from the dashboard panel to help with spacing. In some cases, the data source does not contain a field, or column, that is needed for the analysis. For example, the data source might contain fields with values for sales and profit, as is the case of the Excel worksheet sample, superstore.xls, but not for profit ratio. In such a case, a calculated field for profit ratio can be created using data from the sales and profit fields. The following slides demonstrates how to create a simple calculated field using as data source the previously mentioned Excel worksheet and assuming that is already imported in Tableau Public as shown in the figures in this slide. In a worksheet in Tableau Public, select Analysis and then create Calculated Field as shown in the Figure A in this slide. In the calculation editor that opens, we provide a name to the calculated field, for example profit ratio, as is depicted in Figure B. In the calculation editor we are also provide the formulas shown in Figure B and then clicking OK. The new calculated field is added to the data pane as shown in Figure C. If the new field computes quantitative data, it is added to measures. If it computes qualitative data, it is added to dimensions. Formally, we can include the following elements in a formula. Fields, these consist of the existing fields in the data source and can include other calculated fields and sets. In formulas, fields appear in orange text. Functions, these are built-in operations that can be performed on data, such as count, datetime, sum, find, and day. Functions appear as light blue text in formulas. Operators, these include the standard mathematical operators. Operators show up as black text in formulas. Parameters, these are placeholder variables that can be used in a formula so that the actual value is specified at runtime. Parameters appear as purple text in formulas. Comments, we can add comments to the formulas to provide a level of documentation. Comments show up as a gray text in formulas. Items entered after 2 / marks are considered comments. Now we are ready to use the calculated field in the view. Drag profit ratio calculated field to color and text in marks section as shown in figure A in the slide. The sheet 1 is then formulated as depicted in figure B. We can further fine-tune the look and feel of sheet 1 by selecting square from the drop-down list as is depicted in figure A in this slide. Sheet 1 is then formulated as shown in figure B. Finally, we can adjust the numbers shown in sheet 1, by right-clicking the profit ratio calculated field and selecting format as shown in figure A in this slide. By selecting percentage from the numbers list and defining the decimal places to 0, as depicted in figure B, the final layout of sheet 1 is formulated as presented in figure C. Finally, we are going to discuss the data types and functions that are currently supported by the Tableau Public. Tableau Public supports the following data types in calculation. Boolean, this data type can hold the values true and false. An unknown value arises when the result of a comparison is unknown. For example, the expression 7 greater than null yields unknown. Unknown booleans are automatically converted to null. Date, datetime, for example, March 23, 2020 or March 23, 2020 11:30 a.m. If we would like a date written in longhand style to be interpreted as a date, datetime, we can place the number sign on either side of it. Number, numerical values in Tableau can be either integers or floating point numbers. String, a sequence of 0 or more characters. For example, L12345 and Star Wars are all strings and are recognized by single or double quotes. The quote character itself can be included in a string by repeating it. Functions are pieces of built-in programming in Tableau Public that enable user to manipulate data in various ways. Tableau Public functions fall into the following categories. Number functions, these are functions to manipulate numeric values. For example, finding the sum of a set of numbers or determining the maximum value in a set would be number functions. String functions, these functions allow to work with string values. For example, a string function can be used to determine whether a specific string is located within a field. Date functions, these are functions that allow user to work with dates and times. One example would be to determine the date when a product warranty expires based on the specified number of days after purchase. Type conversion functions, these functions are used to change data from one type to another. For example, a string that looks like a date can be converted into a date value that's valid for use in calculations. Logical functions, these are functions that enable user to test values and then control what Tableau Public does based upon those values. For example, one result can be returned for sales that meet specific targets and a different result for sales that fall below the target. Aggregate functions, these are functions that enable user to perform mathematical aggregations, such as finding the average value or the maximum value in a field. Pass-through functions, raw SQL. These raw SQL pass-through functions can be used to send SQL expressions directly to the database, without first being interpreted by Tableau Public. Tableau Public includes them so that user can leverage database query functionality that Tableau Public might not inherently have. User functions. User functions can be used to create user filters or row-level security filters that affect visualizations published to Tableau Server or Tableau Online, so that only certain people can see the visualization. Table calculation functions. These are functions that enable user to customize how table calculations work. One example would be to limit the number of rows that are used in a calculation. Additional functions. These are more specialized functions that may, for example, be used with certain large data sources such as Hadoop Hive, Google BigQuery, Microsoft Excel, etc. In the Advanced 3 Learning Unit, the series of steps for designing a Tableau Public dashboard which brings together visualizations and creates interactive applications for the end users, were presented. Additionally, the formulation of a calculated field using data from already existing fields of the available data source, the data types as also the functions that currently supports the Tableau Public allowing the user to manipulate data in various ways, were highlighted. This is the end of the Advanced 3 Learning Unit. Thanks for watching this video.